Hello and welcome to Unit 5, our last unit of the first week. In Unit 4, I told you how the external supply chain can be set up. In this unit, I will focus on the flow of materials within a site. Let me call it the internal supply chain. Here, I have given examples of typical material movements within a site. In step 1, a truck arrives at the warehouse and goods need to be unloaded and checked. Next, in step 2, they are put away into the high rack area of the warehouse. Also, components need to be replenished from warehouse to the production area, and finished goods need to be put back into the warehouse or to a picking area. See steps 3 and 4. Before the products are shipped to the customer, they need to be picked from the warehouse and loaded onto a truck, marked as step 5 and 6. There are other material movements needed not shown in the graphics, for example, to optimize space in a warehouse. One of the tasks in a software implementation project is to decide how sophisticated the modeling of your internal material flow needs to be. There are questions to be answered, such as, to what degree do I need to automate processes and how do I gain efficiency? How many system controls do I put in place to avoid human errors? And finally, what level of transparency is required to optimize my processes? There is no right or wrong in how detailed the modeling should be. The business requirements could also change over time, and you might start with a simpler approach like the one shown on the left, with only one area for warehouse and one for production. Later, once your business grows, you might need to model your high racks and receiving and shipping areas, as you can see on the right. In SAP Business Bydesign, we address these flexible modeling requirements with what we call the location layout and the logistics model. Let us have a look at the location layout first. To create a location layout, you first need a storage location. This could either be the site itself, marked as a storage location, or you can create storage locations below a site. The idea of the location layout is to model the physical areas of a warehouse and production location. The layout itself consists of a hierarchy of so-called logistics area, in short LOAs. These are freely definable areas within the location, providing detailed physical and operational information. If you are interested in knowing the inventory levels of goods already unloaded but not put away, then you should have a goods receipt area. If you want the system to guide your warehouse workers to the right bin location, then you should model your high rack area down to the bin level. If you have a rather simple warehouse and workers know where to find the goods, your modeling could be more simple. The site could also consist of several production areas in which production resources are located. There could also be dedicated logistics areas to supply components to production lines. With that, you can see the flow of materials through production. Please note that inventory management is only enabled for the green logistics areas. In fact, it can only be enabled for one level of the hierarchy. Once for a logistics area the inventory managed indicator is set, you will be able to store products there. Let us have a first look in the system. In the Workcenter Supply Chain Design Master Data, we have a view Locations. In that view, you can see all the sites which got created based on the business residences of organizational management. Here we also have a site, Almica Heating Cleveland. Let's first have a look at the site itself. Here we can find data like the address of the site, and we can also have information like the time zone the site is in or the site calendar. On the right, you find further rules of this site. It can be used as a ship from location or as a ship to location, but also you see that it's marked as a storage location. This means we can create a layout for it. Let's have a look at the layout itself. Here in the table you see the hierarchy of logistics areas. You, for example, see a logistics area for bulk storage, you see a simple warehouse, and you see a high-racked area, which has a structure below it. You see that the high-rack area is modeled down to the bin level. Let's select the first bin for now and see what data can be maintained. I will not show each and every data, but only focus on the most important aspects for now. First, you see that we have the inventory managed indicator activated. That means you can store products on this logistics area. Another very important parameter is the logistics use. This logistics use defines how this logistics area is used in the logistics processes. Here it's used for storage, but you can also assign further logistics usages to it. For example, it could be used for shipping staging or for receiving staging if I assign additional logistics usages for it. Let me remove that line for now. Now let's have a look. Also, we can define certain restrictions of this logistics area. You can, for example, define that only the same product is stored at one point in time. You cannot mix products in that bin. You can also define which products are allowed to be stored there. In this example, on that bin, I can only store handsets. Now let's move to the production. Here we have a list of resources which are assigned to the production area. These are production machines, for example, that are used in manufacturing. You can also see a fixed supply and output area. With this supply and output area, these are again logistics areas, which are then used in manufacturing. And the fixed supply area is used to pick the goods from there to fulfill a production order. After production, the goods are stored in the output area, here in the warehouse. So let's have a look at this production supply area. It can be found below the production logistics area. Let me select it. It's again inventory managed, and we have so-called replenishment and removal rules. Here only the replenishment rules are maintained. So what do these rules do? They define when goods need to be brought from the warehouse to this production supply area. In this example, it's demand-based replenishment type, which means that only goods are brought to the production supply area when we have open production orders. I will skip the material flow rules for now and return to the presentation. The other master data to control the internal material flow is the logistics model. It describes the steps of operations of a logistics process. We offer different logistics models for the standard receiving and shipping, replenishment and removal, returns, and spare parts process. In a lot of cases, a logistics model consists of one operation, but there are logistics models that can have two steps, like for shipping of goods to customers. See the example 1 on the slide. Let's have a closer look at this model. In a first step, we pick the goods from a warehouse and bring it to the shipping staging area, and in a second step, the goods are loaded onto a truck. For each step of the logistics model, you must define the logistics use of the source and destination logistics area. This is needed for the system to automatically propose logistics areas. when tasks for the warehouse workers are created. Of course, only logistics areas that are inventory managed and have the correct logistics use assigned can be proposed. In our shipping example, the goods should be picked from a logistics area with logistics use storage. The goods should then be brought to a logistics area with use shipping staging. In the load step, the goods, of course, are taken from source logistics area of use shipping staging, but the target logistics use is not defined because the goods are not in our warehouse anymore after loading. Now to the second example. For a replenishment task, you remember that the replenishment rules were defined for the target logistics area. Therefore, the target logistics use does not have to be defined in the logistics model. Nevertheless, you'll need to define the source logistics use. There is one element missing. We still need rules that help the system to determine the specific source and destination logistics area. Imagine you have set up a location layout with multiple logistics areas of the same logistics use, for example, storage. Which of the logistics areas should the system propose? You can define this in the material flow rules. They can be set up on site level and on any hierarchy of the logistics area. The system always tries to use the most specific set of rules. Let us take a first example, a shipping process. In the one-step process, the goods will leave our warehouse after picking. Therefore, the system will always consider the material flow rules on site level. Let us look at the second example. In the replenishment process, we learned that the rules are defined for the target logistics area. Thus, the system will first check if any material flow rules are maintained for this logistics area. If no rules are maintained, the system will go up the hierarchy of logistics areas until it finds some rules up to the site. If no material flow rules are defined at all, the system will apply default rules. Let us once more go to the system. In the Warehousing and Logistics Master Data Work Center, we have the view Logistics Models. Let me open the logistics models for standard shipping. You see that this logistics model has only one operation, which is the shipping pick operation. Let's select the operation and look at the source and destination logistics use. You see that the source logistics use is maintained as storage. This means when picking goods to ship to the customers, the system will automatically propose logistics areas with the source logistics use storage. As said, the destination logistics use is not specified because after a one-step picking, the goods have left our warehouse. Now let me show you where you can find the material flow rules. Again, I go to the Supply Chain Master Data Work Center View Locations. As you have already seen before, the material flow rules were on logistics area level, but also I told you that they could be maintained for a site. You can find them in the site UI on the tab Material Flow. You can either define basic rules. Oh, sorry, that was the wrong site. Let me select another one. You can have, first of all, basic rules. This is nothing less than a fixed source and destination logistics area. These rules might be sufficient if you have a very simple layout. If you have a more advanced layout, we can define advanced rules. First of all, we have a sequence ID. You see that the sequence ID is specific for a certain logistics area use. Here storage. So this means this sequence ID will be used for our one-step shipping process. Down here you see a sequence of steps which are taken to look for inventory. First, the system will look in the warehouse for goods. It will use a picking strategy FIFO, which is first in, first out, meaning that the goods are picked from the warehouse which first entered the warehouse. If no inventory can be found in the warehouse, the system will look at the high rack area, again using a FIFO picking strategy. Now imagine we have another area. You remember we had the bulk area, and I want to use this for picking the goods in the outbound process. So how do I do this? First, I define a new sequence ID. Let's call it bulk. And again, since I want to use this in the picking process, I assign the logistics area use storage to it. Now, down here I can define from where to pick the goods. And since this is bulk material, I will use the bulk storage. And in this case, just a minimum movements, because I want the warehouse workers to have as few tasks as possible. Let me save this. But still, the system doesn't know which sequence ID has to be used when. This can be specified in the sequence determination. Let me add one row. And here I first select the sequence ID. Let's first use the sequence ID which I want to use for non-bulk material. And I assign the storage group to it. You remember this storage group could be assigned in the material master data on the logistics tab. And I assign the non-bulk storage group. And for the other sequence ID bulk, I assign the storage group bulk. Now the system first checks the storage group of the product, and with that it will determine the sequence ID which is used. Let me save and close this and return to the slides. This concludes Unit 5, our last unit of Week 1, where we have had a look at the various location definitions and how to model the internal structure of a site using the location layout. We also have understood the role of the logistics model and the interaction with the location layout. Finally, I introduced material flow rules. I hope you'll enjoy the course. My colleagues and I would be happy to see you in the next week.